already had one session on big data analytics, so maybe you are aware about what exactly the meaning of big data. I'll give you a quick recap what exactly the meaning of your big data. So when we can say a data is big data, when we have a large or massive amount of data set which we cannot process. Actually, there are a different data handling tools or data processing tools. So the tools can be different in case of if you're working with your normal data and if you're working with your massive amount of data, which cannot be handled with your traditional tools, then that you can say it is our big data. That is one of the criteria to identify whether my data is a big data or not. So you can say big data is a massive amount of data which cannot be processed or analyzed by using your traditional tools, which we use with your database management system and other tools. So let's take one example I have mentioned here as well. We all know about Facebook, Twitter, or Instagram. All these are your social networking sites. They are generating a huge amount of data on daily basis. So we can say that data is my big data. We cannot say in an organization we are generating a bills every day and that bills are in a very structured form and having a very limited amount of data. So that cannot be a big data. But in case of Facebook, on every day we are generating 500 terabytes. So you can imagine that which can be considered as in big data. And one more thing which is associated with big data is it can exist in different forms. Like your data can be in your structured data, like we store in our Excel files or our database systems, or your data can be semi-structured data, like your emails. The data generated by your emails, you are sending an email, you are receiving an email, it is having a proper structure, like there is a field to, there is a field for CC, BCC, subject, but the content which is attached with the email can be unstructured, or the text written into a email body can be your unstructured. So you can see there are specific fields related to your email, but the data stored or data shared through that email can be unstructured. That's why we are saying it is a semi-structured data. And in case of unstructured data, what can be the different type of data? That is like we have videos, text, you are creating a blogs. Blogs can be one of the form of your unstructured data. For example, we need to take some data from our blogs. So you have that unstructured form of data, then you need to convert it into some structured form so that you can perform the analytics onto that particular unstructured data. So big data is basically is a combination of all types of data and having a huge volume of your data. So there are three important terminologies which we are using with our big data is your volume, velocity. If it covers all these criteria, then you can say your data is a big data. Then only we will use our big data analytics techniques or tools. Otherwise, we will use our traditional data analytics. So before selecting your analytic tool or before selecting your process, which process is to be applied for analysis, that purely depends upon the category of your data. So that is the basic idea what exactly the big data is. Let's move to our actual topic, that is your big data analytics. So everybody heard about, like nowadays it's a very hype word, data analytics, your data science, your business intelligence. So all these are interrelated terms, but what exactly how we can define our big data analytics? It is a process which is used. It's not like it's not a technique or it's not like a technology which you are using. It is complete. It is a complete process which is used, or you will apply that process to extract meaningful insights such as your hidden patterns in your data, unknown correlations which exist among your data, to understand the different market trends or the customer preferences. Obviously, we are running the businesses and we have the data related to our business or related to our organization or related to any other thing. So in that case, we want to find out the meaningful insights or the meaningful trends out of that huge amount of data. Now the big data analytics will apply is a process which generate those insights. So there can be the different advantages which can be used for your big data analytics, or from your applying that big data analytics. It can help you in your better decision making. Obviously, if you have some trends with you, and with the help of those trends or the previous trends from your already available data, that can give you the direction that what decisions you need to make for your future. So it will also help you into that. It will also help you in preventing the fraudulent activities which can occur in a future as well, or which was occurred in a past also, and lot of other things. So what I can say, we can say here, like big data is, you can say, a step-by-step methodology, or big data analytics is a step-by-step methodology which is needed to organize the activities or the task involved into this process. Now, why big data analytics is important? Why it is so important that everybody is talking about big data analytics nowadays? Why we are saying it is important? Because we have in by using your normal tools, by using your traditional tools, you cannot analyze your data which is available in huge amount. And sometimes without, if we are making a decision without analyzing those data or without analyzing that data, then it will be definitely you can make a decision which can fire back in a future to you as well. So that's why we are saying big data analytics is important. And if we want to directly interact with our big data, it's very difficult to understand that data. So we'll analyze that data, we will generate a trends out of that data, and we are checking those trends, or we are checking those analysis which we generated from the big data, and make a decisions. And again, that analysis or that trends will be generated in such a form that a non-technical person can also make a decision on the basis of that, and then that analysis which was generated by your those tools. So that's why we are saying big data analytics is so important nowadays. Now come to the life cycle of your big data analytics. In and total, there are 9 phases in your big data, or 9 steps or stages in your big data analytics. Big data analysis differ from your traditional analysis due to like the volume, velocity, and variety characteristics of your data being on which the processes are to be applied. To address those different requirements for performing the analysis on big data, will generate a step-by-step methodology, which is required to organize different activities and tasks which are involved in your acquiring or processing or analyzing or repurposing your data. So further, we will discuss how we will explore the different data and how the data is processed in during these all 9 stages. So big data analytic life cycle will organize or manage the tasks and activities associated with the analysis of your big data. So first of all, the first step into that is your business case evaluation. So I'm just naming all these steps first. First one is your business case evaluation, then data identification, then data acquisition and filtering, then data extraction, then data validation and cleaning, data aggregation and presentation, data analysis, and data visualization. From here, you can see from this diagram, data analysis and data visualization are your iterative processes. You will analyze your data, you will generate your visualization, then if some improvement is required, then again you will perform your exploratory data analysis task over there, and then you will generate a visualization for a new analysis you run on your data. And then that visualizations will be provided for utilization in your organization. So we'll discuss each and every step in length so that you could able to understand what is the meaning, or what processes we will do under every stage. So first one is your business case evaluation. Like in case of each big data analytic life cycle, we will start with a well-defined business case. Why we need a well-defined business case? Because that business case will provide you the understanding about why you are carrying out the analysis task on your data and what are your target and what are your goals of carrying out that analysis. So that's why it is very important. It's a very important stage of your business data analytics, that first of all we need to identify what is our goal, what are our different goals to be achieved by performing that analysis. So it requires it helps, or you can say it helps the business organization CEOs or your decision makers to understand the business resources that will be need to be utilized and which business challenges the analysis will tackle. Further, the identification of KPIs can be done during this stage so that we can identify, we can determine what can be the different assessment criteria. KPIs are here the key performance indicators of your business process or any department of your business organization. So what are the different KPIs on the basis of which we are evaluating our analysis results, or on the which basis we are identifying whether the analysis was run successfully or not. Sometimes it's possible that we could not identify the KPIs at our first stage, like while developing your business case. So in that case, what we can do, we can generate the goals of our analysis project defined as in SMART, where SMART will define the specific, measurable, attainable, and relevant and timely goals of your analysis project. So otherwise, what can be, if you are not able to identify the specific indicators or metrics which can be used to analyze your analysis task or the results generated by your business big data analytics. So in that case, if it is not possible at the first stage, you can use your SMART technology, which will, or the SMART keyword, which can define the goals of your analysis. At least those should be clearly defined while your business case evaluation was done. So based on your business requirements that are documented in the business case, it can be determined whether the business problems being addressed are really big data problems. Like what I earlier told you, that first of all, we need to identify that these are my requirements, whether on the basis of that requirements, whether it's actually a big data problem or not. That is to be identified on the basis of whatever requirements are documented in your business case evaluation stage. So in order to qualify as a big data problem, a business problem needs to directly relate it to one or more of the big data characteristics like volume, velocity, and variety. So at least one characteristics of your big data should be available with your data available on which you want to perform the analytics. So if no one of that characteristics is applicable to your data on which you want to perform the analytics, then no need of using your big data analytics. In that case, you can use your simple data analytics techniques and tools. So that is very important, that identification of your of your requirements, whether that is your big data problem or not. Then another outcome of this stage can be the underlying budget required to carry out the analysis project. So that means cost is again very important. So we need to identify what is the budget requirement to carry out that analysis. Sometimes the organization is not having that budget so that they can run that business data analytics. So the first step, very important, is requirement generation and then identifying the budget for that, whether it's feasible to run that analysis or not. And then any required purchases, like sometimes it could possible we need to purchase some tools, we need to purchase some hardware, we need some trainings to be conducted for our employees to run that analysis task. So that must be understood under your first stage only. So we need to identify those investments in first stage only, and then we need to do a cost to benefit analysis of your required budget for running the analysis, and then what is the expected benefits out of as an outcome of that particular analysis. So that means you mentioned a goal. What will be the benefit if you will achieve that goal of your analysis? You need to perform that cost benefit analysis, that this is my investment and this is my benefit out of this particular analysis task, whether it's advisable to run or not. So that means we will need to check that also in a first stage of our big data analytics. I think I'm, is it okay with everyone? Everything is going fine. I am audible. Yes, anyone, please respond. Am I audible?
Yes, ma'am, you're audible.
Okay, it's going fine now? Fine.
Yes,
Okay.
ma'am.
Because in case of online platform, you can understand that
Yes,
like we
ma'am.
could not able to see whether it's audible or visible or not. So, okay, that is our first step, which we already covered in detail, that first of all, we need to identify our business case. Now, after identification of our requirements, after identification of our tools, resources, and the budget, first of all, we need to identify the data on which we want to run the analytics. So data identification is dedicated to identifying the data sets required for analysis project and their sourcing. Identifying a wider variety of data sources may increase the probability of finding hidden patterns and correlations. So if we have a wide variety of data, then there is a probability that you will generate a hidden information out of that particular data. For example, to provide the insight, it can be beneficial to identify as many types of related data sources as possible, because when it is we don't know what exactly we want out of our analytic task. In that case, it is more important that we will cover more and more data so that it will generate more beneficial insights or more trends or more correlations out of the existing data. So in that case, when the goal is not clear, we don't have the clarity of exact outcome of our analytic task, then it is more important to include more data, and we include more data set. So there, that your data sources or your data sets, data sources can be of two categories in in any of enterprise, that is your internal or external. Internal data sources can be the data marts available in your organization, operational systems available in an organization, or your data warehouse, etc. So I think everybody is aware about these terms, data marts, data warehouses, or should I need to mention those? Anyone, please?
I hope everyone is aware, ma'am, of these terms.
Okay, fine. So depending upon the business scope or analysis of your project or the nature of your business problem being addressed, we require the data sets which can be your internal or external. Internal can be the data which can be available within your enterprise, within your organization, but can be in different forms, like your data marts, your RDBMS database management system, your operational systems, your data warehouses. But external data sources can also be there, like you can purchase the data from your third-party data providers, such as the data available in your data markets or the publicly available data sets or data within the blogs. Yes, I earlier mentioned as well, the data can be available in some form of your blogs or on some content websites or on your social media networks as well. So these can act as in your external data sources. So definitely for success of any of your project, you may include your internal data sources, data from your internal data sources and external data sources, which are very important. So We need to, but in case of your external data sources, like your data within blogs or content websites, in such cases, we may need to invest on some automated tools which can convert or fetch those data and store into your data sets, which are in some uniformed view from which you can apply the analysis task. So means some additional processes to be applied on your external data sources, which are not your structure, which are not available in your structured form, which cannot directly use in your data analytics task. So again, data identification is again very important. If you have not identified your data correctly, or if you have missed some of the data, then your trends can be your misleading or misguiding. So it's again a very important stage or phase of your data analysis task. Next is your data acquisition and filtering. Obviously, we collected the data, we identified the data, that these are the different data sources from where I needed data to be collected for my analytics task. But now exactly means now we need to acquire that data and filter out that data. Means now the data is to be gathered from all the data sources that were identified during our previous stage. So my data acquisition and filtering will emphasize on the gathering of your data from the different data source. The acquired data can be subjected to automated filtering for the removal of your noise from your data, or the corrupt data, or the data which has no importance related to your analysis goals or objectives, which was defined in your during your business case evaluation. So means now we need to filter out the data which is important for our analysis task, or for our business, or which matches with our objective or goals of our analysis objectives. So we do not need all the data, we need the filtered data. Now, depending upon the type of data source, data may come as in collection of files, or such as you have purchased the data from your third party data provider, as I earlier told you, or you may need a data from your Twitter. In that case, you need some API integration with your systems for data acquisition. So it's means you are collecting the data from different sources. Here I mentioned the one term, that is your corrupt data. So corrupt data can include your missing data, non-important data, or some error data is there, or some invalid data types are there, some invalid values are there. So that data can be considered as in corrupt data. So for your data analysis, for this analysis task, we need to filter out that data. Means there should not be no error in your data, no corrupt data should be there, no missing values should be there. So before applying the task, we need to clean our data. We need to filter out our data from the different sources. Now you filtered your data from, you collected, you acquired the data from different sources, and then applied the filtering onto that data. During filtration, what you have done, you ignored or you deleted few of some of the data which is not required for this particular task which you want to applying it now, but it could possible that data may be required for some another analysis task. So it's always advisable to store a verbatim copy of your original data set before proceeding with the filtering. You need to create a copy of your collected or acquired data before applying a filtration. Maybe that filtered out data is not useful for now, but in future you need some other analysis tasks to be performed. Then you can directly apply it onto that acquired data from different sources. Then you do not need to repeat the process of your data identification and data acquisition again, which will save your time in the future. So that is a advised from your business analysis task, that do not need to repeat those steps again and again. Now again, during your data identification and filtering, one important part which plays a very important role is your metadata. Yes, everyone knows that the metadata is your data about data, which will tell you about the data which is stored in your different data sources. So metadata should be added in the both internal and external data sources, and there should be some automation tools which is used to add that metadata, and metadata should be machine readable. If it is not machine readable, if it is not properly structured, then it is very tedious to understand your data which is stored in your different data sources. So when you are acquiring a data or merging a data and filtering out a data, then metadata plays a very important role. And your metadata is not important only for this phase. It should always be forwarded to further stages of your data analytics task, because it always give you the information about your data on which you are applying the analysis. So that's why it is forwarded to the further phases also of your big data analytics. So that is your data acquisition and filtering. Next is your after acquisition and filtering. We filtered out our data which is required. We stored that data only. But the next step is your data extraction. Now we need to extract the data from different sources from the filtered data, and we need to convert that data into some different forms also, so that it can be used for your data analysis purpose. Because it's not always like your data is available in a form which is can be directly used for your analysis purpose. So means we need to perform some transformations. So I have given one example over here. So you can see in that example, some website data is there, some transactional data in the form of your online XML document form is given over there. So there are some comments, transaction IDs are there, user IDs, their date is mentioned over there. So from here, we can use directly, we can extract the comments with respect to one particular user ID from our XML data. Means we do not need to apply any transformation. It can be directly stored into your in some structured format. But sometimes it could possible your data is not in that structured format. Then we need to apply some transformation techniques also. Let's take this example. What is given over here? You can see a user ID is given, name is given, and that is in some of the JSON field. A single field is given over here. So in that single field, what was mentioned, that your user ID, name, all are stored as in single field. But to perform analytics task, I need all these fields as an individual. So that means we need to extract the data from a single field and store it into a different fields to perform our analysis task. So the data extraction is very important. So because this is a phase or this is a stage which converts your data in a form which is on which you can directly apply your analysis. So the extent of extraction or transformation required depends on the types of analytics and capabilities of big data solution. For example, like I'm taking one example, or like extracting the required fields from the delimited textual data. We have a textual data which is separated by some delimiter, such as your web server log files. So in that case, it may possible that your big data solution can directly access those files. No transformation is required, but for sometimes some transformations are required. So it will purely depend upon what type of data you have and what type of analytics you want to perform. Excuse me, everyone. There is one urgent call. Just Sorry, everyone. There will be some urgent call. Whether my screen is visible yet or not?
No, ma'am, it is not visible as yet.
Okay. I'll share it again.
Yes.
Is it visible now?
It is not. Yeah, it is visible, ma'am. It is visible now.
Okay. Thank you. So we are discussing like what level of data extraction or transformation is required. That will purely depend upon what is your target and what type of your data, different type of data sources are there. Like if sources are in a structured form, already in a form on which your big data analytic tool can work, then no need of data extraction and transformation. But if the data is not available in that form, then you need to extract and transform your data. So the data extraction is purely optional thing. If it is required, then you need to do, otherwise it's not required over there. The next phase or next stage under your big data analytics is your data validation and data cleansing. Data validation and cleansing stage is dedicated to establishing often complex validation rules and removing any known invalid data. Like invalid data can, first of all, I'll tell you what can be the problem because of your different corrupt data or invalid data. Invalid data can skew and falsify our analysis results. Like traditional enterprise data, where data structure is predefined and data is pre-valued. The data input in big data analysis but can be unstructured without any indication of validity. Excuse me, ma'am. Sonia.
Yes, ma'am.
Sorry, I'll कोई बात नहीं. वो it was mic was on.
Oh,
That's why I asked.
sorry.
It's okay. So let me discuss it again. In case of data validation and cleansing, we work with our invalid data or our corrupt data. So why it is required that we will perform the data cleaning and why it is so important? In case of invalid data, if the invalid data is available in your data source or in your data set on which you are applying your data analysis task, what happens? It can skew your results, it can falsify your analysis results, which is like affect your decision making process. Like unlike in traditional enterprise data where data is structured, which is predefined, which is pre-validated, pre-evaluated data into a big data analysis can be unstructured data without any indication of validity. Why we are saying there is no indication of validity? Like you are fetching a data from Twitter, whether there is any validity of that data? No. That means we need to validate our data, whether that data is proper or according to our analysis task or not. So that means in case of big data analytics, data validation and cleansing is very important. So this stage is often used to establish your complex validation rules and removing any unknown invalid data. Big data solutions often receive redundant data from different data sets. This redundancy can be exploited to explore interconnected data sets in order to assemble your validation parameters and fill in the missing valid data. That can be used, that redundancy can be used, but it will be like a overhead or a burden for your analysis task if there is a lot of redundant data in your data sets. So that should also be removed, which is very important. Let's see one example I covered over there. In that case, there are two data sets. First one, data set A and data set B. In case of data set, there are few records. In case of data set B, there are also few records. In the first value of data set B is validated against its corresponding value in data set A. You can see the first value against the first value, there is a value available in your data set A. So that is validated. But when the second value of data set B is not validated against its corresponding value in data set A, then that means that is your invalid data. We cannot say it both are same, not are equal. We cannot validate that data. Or sometimes it could possible the value is missing in your second database but available in dataset A, then we can insert it into a dataset B as well. So now you can see during a validation process, we can validate the data also, and we can use the different data sets for filling the missing values also. So by filling the missing values means we are cleaning our data, we are removing our missing values from that. But for like if I'll take an example of your batch analytics, in that case, data validation or data cleansing can be done via an like offline ETL operations. Everyone knows about that ETL, extract, transform, load operation. Like before applying your data analytics, what we will do, we will apply the ETL process and store our data into a uniform form and then apply the different analytic tasks. So in case of batch analytics, we can perform offline ETL operations. But for real-time analytics, more complex in-memory system is required to validate and cleansing the data as it arrives from the data source directly. So here, we need to determine the accuracy and quality of your data, which is always questionable in case of your real-time data. In case of like your data from your social media, data from your different other websites which are generating data at every seconds, every milliseconds. So we need to, that the quality of that data is always a question mark. We need to validate that data, we need to cleansing that data, and in that data what could possible, there would be a maximum data would be like considered as a noise. You have a very little amount of data which can be used for your analytic task. So we need to identify that. And sometimes it could possible data that appears to be invalid, that can be a valuable data, and that may have some hidden patterns and trends. So now you can see here, like here, there are spikes in your data which can show the outlier behavior of your data. But sometimes in case of fraud detection, like I want to apply my big data analytics for your cyber crime or cyber security purposes. In that case, you want to identify any fraud or anything else. So in that case, your abnormal behavior is important over there. So in that case, that invalid data can also give you some trends or some insights. And that presence can be shown if I'll use that line graph or time series graphs, that can be shown as in spikes into your that particular trend. But yes, presence of your invalid data should be cleansed before applying your data analytic task. In generic cases, in normal cases, or in you can say in your day-to-day times whenever you need to apply your big data analytics. But for exceptional cases, sometimes it is important for us as well. So now we cleaned the data, we validated the data, we extracted the data from different sources. The next is related to representation of your data and your integration or collection of or storing of your data into one structured form or one unified form. So that step or that phase is called as in data aggregation and representation. Data aggregation and representation stage is dedicated to integrating multiple data sets together to arrive at a unified view. Here the aggregation and representation, what it will do, aggregation means aggregation of your data. You have multiple data sources, and under those multiple data sources we have multiple data sets. On those data sets we are going to work, and then for that we need to aggregate that data. We need to integrate that data in a single form, in a single view. It could not possible one data source is having a data in different form, another data source is having a data in different form. But for my big data analytic tool, I need to convert or transform that data into a single form. So for that, for this stage, there are like different tasks are over there. We need to work onto the data structure of our data and the semantics of our data. Like data structure means data format may data model should be same. Like you are using multiple data models, but what will be the structure of my data in those different data models, that should be same. Your models can be different, but the form or the structure of your data should be same. Like your fields or you can say the attribute names should be same, so that they can be integrated into a single form. So data structure plays an important role over here. Another one is your semantics. Like we are storing the name of a person in our data set. While storing a name, there could be a first name, middle name, last name. But in one data set, it is stored as in surname. In another data set, it is stored in the last name. But both are having the same meaning. So we need to identify that as well. Like two different data sets can be labeled, the data can be labeled with different names, but their meaning are same. The values stored in that fields are same. So we need to identify, and for identification of these two things, the metadata plays a very important role, because metadata will guide you what are the meaning of these different values and what type of values are stored in different fields, whether they are storing a same type of data or no, not in a different sources. So here also your metadata is important. That's why we said that metadata should be supplied to the further stages also. Let's take one example here. In this example, what we considered, we have, if I'll see the first figure, where the three data sets are given, data set A, data set B, and data set C. So this is a very simple example of your data aggregation, where two data sets are given. Both are having one field common, that is ID, and another data set is in data set A is having one different field as a name, and data set B is having another name as a date of birth. But data set C can be very easily generated from these by combining these two data sets. That is, ID is common. We can simply apply the join operation onto those two data sets and generate a third data set out of these two. Very simple, very easy. But sometimes it could possible your data sets can have the different types or different data structures. Like here in the second example, here data set A is having key stored as in key value pair. If anyone studied about Python, you can see there the data can be stored in a internally can be stored as in key value pair, which can be one of the way to store your data. So here the data is stored as in key and values, means all with respect to one key, all the record information related to one record is stored as in a single value. But in case of data set B, what happens? The data is having a uniformed form, like ID, name, date of birth, all are stored as in separately. So in that case, what we need to do, we need to convert our key value pair into some uniform structure and then store into the resultant one. So this will what will happen here? We need to convert the data sometimes into, we need to convert the structure of our data sometimes before integration and before aggregation. So while applying the data aggregation, there are like two approaches. One is your schema integration and another is your instance integration. Schema integration will work on this structure, which we already covered, like what is the structure of your data. But when we are talking about the aggregation of your instances, aggregation of your records, storing of your records into that, what happens? It could possible in one data set, I have the, like I want to store a gender. In one data set, the gender is stored as an M and F with the values as an M and F. But in one data set, it can be stored as a male and female. So what happens in that case? You need to transform the data so that your data will be in a single form. Like if you'll combine a data without transforming, what will happen? Some of the records are having a gender value as an M and F, and some records are having a value as a male and female. And when you run your analytics, like on the basis of category of your like gender of your customers, you want to analyze something. So it will not give you the correct results because it doesn't know whether the M, you need to run a query or you need to run your analysis on the basis of male, female, or M or F. So it will remove few of the, it will not consider few of the records for your analysis tasks, and it can generate you the misguiding or misleading results. So that's why the schema integration, the aggregation at the level of schema is also important, and the aggregation at the level of your instances is again very important. So that is your data aggregation, and we need to take care of all these things while applying the data aggregation. Is it okay, everyone? Anybody is having any doubts or anything you want to ask till this point? Sorry, I have not asked it earlier.
Anyone, any doubts? You can put up in the chat window, or you can raise up your hand. Ma'am, you can carry on.
Thank you, Sonia. So next is the most important stage or most important phase of your big data analytics is your data analysis, where actually the analysis is done. Till the point what we are doing, we are preparing our data for analytics task. But from this stage onwards, or in this stage, actual analysis will be done. So data analysis stage is dedicated to carry out the actual analysis task, which typically involves one or more type of analytics. Let me give you the idea about the different type of analytics first, then we will move further. Here broadly given it as an confirmatory analytics and exploratory analytics. Confirmatory is like you are whatever the facts, figures which are available in your data, you are only confirming those and you are generating the trends out of it. But in case of exploratory, what happens? It will generate the unidentified patterns out of your data. So basically, majorly, we are working on exploratory data analytics. But in data analysis, there are one more criteria on the basis of which I can define different type of analysis which we can perform under our big data analytics. First one is your like descriptive analysis, which comes under your confirmatory analysis. Means it will tell you what was happened by analyzing your data, what was happened in your organization, when it was happened, and what was the frequency of happening some incidents in your organization. Means it will give you the answer of what and when and how many times. So it will give you the, it will describe your data only. There is no prediction is there, no recommendations are there, only describing your data. You are describing your data, you are generating the reports out of your data. So that is your confirmatory data analytics. Next is your, one is your uh, descriptive analytics. Next is your predictive analytics. Let me give you the predictive one, which is the most important one, which many of the organization or most of the organizations are nowadays using. Each and every analytics is used in one or other way, but predictive is the most important, because what we are doing here, we are generating a models out of our data. We are generating some intelligent models. We are applying some machine learning techniques over there, some statistical techniques over there, and generating a model for out of that data. And then that model will predict for anything for you in for future. Like for example, I want to predict what should be my investment for our next quarter. Like how much investment I need to do. So how I can identify it? So you have the previous data available with you. You have your real-time data also with you, current data also with you. You will apply your analytic task. You will do the predictive analytics from your historical data, from your real-time data, which is available in your organization. And then we will generate that model. And on the basis of that model, it will you will identify what should to gain a profit, to generate a revenue, how much investment you need to make. And on the basis of the result or the insights generated by that predictive model, you will make your decision. So you can see it can be applied in any area. It can be applied like in medical area also. In your medical data is again a very huge amount of data. So if you want to apply some analysis onto that also, then you need to apply some big data analytic techniques. And that is again one of the futuristic trend in your big data analytics, that merging of your machine learning and AI with your big data analytics is very crucial or very important area, because some of when you are applying a machine learning tools or machine learning techniques on your already available data, it can take some time. And if you want to work with your big data, you need to optimize your machine learning techniques so that it can provide you the insights or generate a trends for you. So let's come back to this step only, that is data analysis. Here we can generate, or that analysis step can be repeated iteratively until the appropriate results, appropriate patterns or correlations is uncovered. So that means it's not applied only once onto your data. You need to apply it again and again. So that is your two different types of data analysis. So we covered like what is confirmatory and what is your exploratory. Exploratory means no basis is given, no goal is given, nothing is given to you. It is an inductive approach. You will perform the exploration in your data through analysis and develop an understanding or the cause of a particular phenomenon, like prediction. Another can be your prescriptive analytics, can be the part of your exploratory data analysis. Now, what is your like prescriptive analytics? Here, you performed the prediction, you generated that this may happen in future. This can be the steps I can perform. But you generate the trends or patterns or insights. You generated a model. But what prescriptive analytics will do, it will give you the recommendation. What should you do? What should be done by you? What action should be taken by you? Those recommendations are done by your predictive analytics. So that means you to perform all complete task, it could possible you have to perform the confirmatory analysis also and exploratory analysis also. So it can be the combination of both the analysis. Confirmatory is done only once on your data because it's a deductive approach. You will test your hypothesis, you will make some assumptions, you will say whether that assumption is you are you will analyze whether it can be proved or disapproved. You need to accept that hypothesis or reject that hypothesis. But in case of exploratory, you need to explore your data by applying your different intelligence methods, different data mining tools you can use over here. So that is a most important phase of your big data analytics process. But definitely the success of this stage or the success of this step will purely depend upon what was the quality of your data which you gathered from different sources, and how you represented that data, that the representation of your data is in a form that it can generate the trends, or it can explore the different hidden patterns out of your available data. If that data is not valid data, the data is invalid, then the result may be incorrect or invalid. So next is, after applying the analysis, it has generated a trends. It generated the information for you on the basis of which you can make a decisions. But as a technical person, it's very easy for us to understand those results which were generated by my data analysis stage. But I'm not the only person who needs to take a benefit out of that analysis task. There could be different business users also which are using those results or the patterns which was generated by your data analysis phase. So for that, we need to use some data visualization tools or techniques so that your results or the patterns can be communicated graphically, can be communicated in such a form which can be understandable by your business users of that particular analysis process. So the result of completing the data visualization stage provides the users to ability to perform the visual analysis and allow the discovery of answer to the questions that users have not formed yet. Sometimes it could possible at the time of starting, you've given some of the questions like I want the answer of these questions, but while completing your complete business analysis task, this big data analytic task, what happens, you will get some more information that the those you will get the answer of those questions also which was not raised in your first stage or raised at your first stage of this complete life cycle. So data visualization can also help you to uncover those results. Excuse me, everyone, just 1 minute. Yes, come in. So in case of data visualization, again, if you are not representing your data in a form which can be used by any type of user, then it's of no use. So analysis was done, collection was done, but you could not able to transmit that result, or you could not able to represent in such a way that everyone can use it, then there is of no use of implementing that. So data visualization also plays a very important role. Next is your utilization of your analysis results, which will be the final phase of your big data analytics task. Subsequent analysis results being made available to business users to support your business decision making, such as your dashboards can be used. You can have your scoreboards also. You can have some other like you generated a trends in form of some graphs, pie charts. So that can be provided to your business users for their support so that they can utilize those analysis results for determine how and where the process analysis can be used. So the utilization of analysis result is stage is like to determine how and where my processed analytics can be further used or and can be used in future. Depending upon the nature of analysis problem being addressed, it is possible for the analysis result to produce models that encapsulate your new insights, new trends, new understanding about the nature of pattern and the relationships that exist within the data that was analyzed. The model may be like your mathematical equations or your some set of rules, and then models can be used to improve your business process logic, application system logic, and they can form the basis of a new system or a software program. So you can see those results, those analysis results can be utilized in some different ways. Like from the analysis I generated a models, then these models can be utilized at some other areas also, or some for some other similar type of analysis task also. So we do not need to generate that model again and again. We can utilize the same model for similar type of analysis task. The common areas that can be explored during this stage can include the following, like input for enterprise systems. The data like the data analysis results may be automatically or manually fed into an enterprise system to enhance and optimize their behavior and performance. For example, we have an online store which can feed the or process the customer related analysis results that may impact how it generates the product recommendations. You can see on daily basis whenever we'll performing the we are doing some shopping on some website or we are searching about some products, and on the basis of those results or on the basis of your past behavior, it is recommending, the recommendations are made to you. So means we can that customer we have already run the customer related analysis, and the on the basis of that analysis, that results or that customer related analysis results can be given to the input to your recommendation system which is used at an enterprise level. So means the results can be utilized as an input for another systems also. Next is for business process optimization. The identified patterns, correlations, or different anomalies which were discovered during the data analysis can be used to refine your business processes. Like in consolidating your transportation routes, like of a supply chain process. For example, in a company, I want to optimize my supply chain process, and we want and I'm consolidating my transporting routes over there. So models can also lead the information that which can be the best optimized to routes you can use, and what are the different issues with different routes, which on the basis of that or on the basis of past behavior of different routes, the recommendations are made that these are the optimized routes for it. So you can optimize any of business process. I have taken an example of supply chain process, but these models can be inputted as an or can be used in any business process which was generated during your data analysis phase. Next is alerts. Like data analysis results can be used like input for your existing alerts or maybe form a basis of new alerts. For example, you want to create or the alerts may be created to inform users via email or SMS text about an event that requires them to take a corrective action. Means we have the analysis result and we are providing it as an input that these are the crucial tasks which is require the immediate attention. So on the basis of those results, we can schedule, we can create the different alerts for informing the users through email or SMS text about that particular event or some additional event. So now I'll conclude that complete phase. We have 9 phases. We started with the data sources. No, we didn't started with the data sources. Sources come at the second step. We started with the requirements or the goals or objectives of the business analysis task. And on the basis of the objective or goal, we identified the different data sources. And after identification of those different data sources, we collected the data from different data sources and then transformed that data or extracted that data in a form which is to be utilized by your analysis tools. Then after conversion of data into that standard form, the data analysis task is to be applied onto that. Different machine learning tools, different statistical tools, another intelligent tools are applied onto your data to generate the patterns or the trends out of your that available data. And then those data and those trends and patterns can be represented in different forms, or very most frequently used forms is the different dashboards are generated for your organization, for your department, and then those dashboards can be utilized by your organization or decision makers to perform the or to make the decisions. Then those results can further and those results can be utilized further for different processes also. So that is a complete data analysis life cycle, and every phase plays a very important role. If at any stage you are not taking care of the do's and don'ts required for that particular step or particular stage, then your whole task may generate an invalid or incorrect results, and which will hamper your decision making process. So that is all about your business analytics, like big data analytics life cycle. The next part of my presentation is very crisp and very small things I covered over here. I covered some specific areas which can be used as an future trends in your big data analytics. Very important one, machine learning and AI. Everyone knows nowadays it's a hype, and it's not anything new with your machine learning and business intelligence. But now, yes, nowadays we are actually utilizing that technology in our day-to-day life and in our day-to-day operations. So here we need a deeper integration of advanced AI and machine learning techniques into big data analytics so that we can optimize, we can automate our big data analytic process. So yes, this is one of the area where you can work more so that you can integrate those techniques and technologies in your big data analytics. Next one is your real-time data analytics. Obviously, many like it's very easy to apply the real-time your analytics onto the offline available data because you have a time. But if you want to apply that perform a data analytics at real-time form at the time of actual when the data is generated, then it's very crucial to provide the results on time and to work with that real-time data. So again, it is one of the area where you can further go. Next is your augmented analytics. Augmented analytics combines your AI and analytics. Augmentation means inclusion, like we can combine our AI and analytics to assist the users in data preparation, in generation of your insight, or like generation of your visualization. So you can see which what is the benefit of it if I'll augment my AI and analytics into that. The benefit is that your non-technical users can also perform the sophisticated analytics task. So you can see, you can take it as further that how you can make your analytic task easier for your non-technical users also. Next is your quantum computing for your big data. As the quantum technology is, or quantum computing technology matures, and it's like booming nowadays, it's growing at a very fast pace. So it has a potential to revolutionize your big data analytics by solving the complex problems much faster than your classical computers. So there are a lot of implications for simulations, optimizations, cryptography. Then if we'll merge big data and quantum computing, we utilize the quantum computing in our big data analytics, then it would be a beneficial that you will get a faster results for your analytic task. Next is your federated learning. Federated learning allows the organization to collaborate on machine learning model development without sharing your sensitive data. So it is sometimes it's relevant for your industries to follow your strict data privacy regulations like your healthcare and your finance. So in that case, without sharing that data, with the help of that federating learning, we can generate or we can perform the big data analytics. So that can again be the one area where you can work further. You can get a that is a little bit unexplored area where you can work on to that. Next is your big data in your climate science. Big data analytics will also play a crucial role in your climate science by processing and analyzing your vast amount of your climate related data so that you can better understand the environmental issues, or you can address the different environmental challenges, because you are as you can see on daily basis we can see the change in climate. So you can use your, so and that data is again a very huge amount data, so you can use that big data analytics with your climate science, and you can explore that area as well. Next is your big data in healthcare. Healthcare industry is like increasing day by day, and again we are using machine learning, AI, IoT into that. If we are using IoT, machine learning analysis, again IoTs are generating a data, and the healthcare data is again a very huge, in a very huge amount of data, and again unstructured data. So that means big data in healthcare will also plays a very important role, and there is a very scope into that you can work your you can run or your analysis, you can generate your big data analytics in healthcare industry also. Next is your edge analytics, edge computing and analytics. It's a combination of your edge computing and analytics. Edge computing and analytics are expected to become more prevalent and enabling your real-time data processing and insights at the source, like IoT devices, your sensors, which, like if you will include edge, if you'll use edge analytics, you do not need to transmit your vast amount of data to the central servers. You can perform the analytics at that site only, where the data is available, and provide the fast generate a fast analytics. So edge computing and analytics can be merged. You can see into that what can be the different possibilities into this area also. Next is your blockchain for big data analytics security. We know that big data, we are working with big data and we are applying the analysis on big data, and that means that blockchain can be included for your data security, which is again a crucial part of any of the organization which wants to perform the analysis on your data. Security is a very crucial part. So blockchain can be included with your big data. Next is your hybrid cloud and multi-cloud analytics. Hybrid cloud and multi-cloud analytics means here many of the organization, like if I'll say, I'll take we have different cloud providers, We are using the clouds. We are having a data on our cloud. So organizations are exploring hybrid and multi-cloud strategies for big data analytics so that they can take the advantage or benefits offered by different cloud providers while ensuring their data availability and compliance. So you can see, you can generate a big data analytics models which can work with the multiple clouds, which can work with the different hybrid clouds. So that is again one of the important area. Next is your big data in cyber security. Big data in cyber security. Cyber security, everyone knows nowadays, like cyber crime is at at a peak, and it's going to be higher in future as well. So big data analytics will be increasingly used in cybersecurity for threat detection, your anomaly detection, your identification of planned or sophisticated cyber attacks. So you can use big data analytics for in your cybersecurity areas. So these are the few areas where you can use your data, big data analytics in a future, and you can work onto these areas as in your research problem as well. There are a lot of other areas also. You can see that now as the data is exploring in every area, so you can use any area where the big data is available. You can include your big data analytics. So that is all about from my side. Thank you everyone for your patient listening. So if you have any queries, I'm available over here.
Yes, everyone. Any queries, anyone from you? You can just raise your hand so that I'll be unmuting your mic.
So maybe everything is clear or nothing is clear.
I hope it is clear, ma'am.
I
It
hope
was
so.
very well organized presentation, ma'am.
Thank you. Thanks.
Very nicely explained, detailing everything about it. Surely the experience speaks here. Thank you so much, ma'am. Thank you for sparing your valuable time for us. We would be delighted to be engaged with you for future proposals also.
Anytime. If you need
Thanks
anything
a
from
lot.
my side, I am always available.
You can share up your mail ID if anyone wants to.
Okay. I'll share it in a chat box.
Yes, please share your mail ID so that any one of you, any queries, anything, you may be in contact with Dr. Deepa Nehra. She is working as an associate professor with Maharishi Markandeshwar University,
I
Mulana.
think many faculty members are there from different
Yes, ma'am.
institutions. If anybody
Yes.
wants to collaborate with any of the research areas under that big data analytics, machine learning, cyber security, that are my niche areas. If you want to collaborate for any for future, I'm very much open with it as well. So if you need any help, so my ID is very simple. It's deepa.nehra@gmail.com. You can directly
Yes.
contact on that. The chat is not visible to me. So Sonia, you please share in
I'll
the chat box.
surely, ma'am. I'll surely put up in the chat window. Okay. Thank you so
Thank you,
much,
everyone.
everyone. We'll be available tomorrow at 10 o'clock again with the next session. Tomorrow we'll be having a hands-on session on Hadoop, and in the second half we'll be having another hands-on session on big data processing algorithms with graph data analysis, which is very useful in your research domain. Meet you all tomorrow. Have a nice day. Thank you so much. I have shared the mail ID in the chat window. Anyone wants to have an interaction with her anytime, you can leave a mail over this ID. Thank you so much, everyone.